Good morning. John Gelkison here, Electric Vehicle Organization, Southern New Mexico Facebook page. I've been wanting to shoot a video because of a YouTube video I seen last week by Fast Lane Trucks where they tested a Tesla Model X towing a horse trailer that was 4,500 pounds. And the Tesla Model X is capable of towing 5,000. And they ended up, they were getting 350 watt hours not towing, but when they were towing it was well over 800, like 870 watt hours per mile, which reduced the range down to 120 miles. And their conclusion from this test was that electric trucks wouldn't be viable for towing, and that they had a real problem. Like all electric trucks or any electric vehicle, towing any trailer would use 3 times the amount of energy, and it was something peculiar to electric vehicles and not gasoline trucks. Of course, they had no control. They didn't use a pickup truck to tow the same trailer, and they didn't compare the metrics at all. But what they really missed was the aerodynamic problem. They were using the Tesla Model X, which has a low drag coefficient of 0.24, and then they was towing a horse trailer which has a high drag coefficient. I don't know what the coefficient of drag of that particular trailer was, but most trailers are abysmally dirty, aerodynamically speaking, because they have large square backs, and the wake shedding, vortex shedding in the wake area behind the trailer is just horrendous. So I wanted to demonstrate that with some models. So I went and got in my our children's tape play box. We have we're grandparents, so these are grandchildren I'm talking about, and I found some model cars and stuff. I found a model car I could convert into a trailer, and then I went down to Walmart and I bought a model of a Dodge Ram pickup truck, because it's more accurate to what I'm talking about, what they should have been talking about at Fast Lane Trucks. And I bought some Play-Doh to do a little bit of modeling, filling in gaps and so forth. So here we are. I wrote a blog on all this, which is published at the Electric Vehicle Organization site, and it's titled Electric Vehicle Towing, Trailer Towing, and it's about 4 pages, 3.5 pages long, with some tables. And the whole thing is, you need to get into energy flows. You need to get into, well, instead of rating gas trucks at miles per gallon, you need to convert all that to watt hours per mile. And they're not doing anything like that. So let's go ahead and get into it with my models here, okay? And I'm going to have to move this. So you're going to have to forgive me how crude this is going to be. As you can see, this is actually a model car, but I'm using this for our trailer. Now it has 4 wheels, but then it'll set up by itself. And normally trailers are towed, the back kind of looks like this on trailers. Now I know this is kind of a caricature of a trailer, but I want to get you into the points here. Now, the children had this model Hummer here. So let's say we use such a vehicle to tow a trailer like this. So you can see right away that we have a serious problem. The air is really tortured in the front of this vehicle, in the sides. It's slab-sided, and it comes up over the top, and this is the highest airflow right here. And then it comes off the vehicle and slams into the trailer right there. It's tripped up again. So it's tripped up here, and then it's tripped up here. And then with this trailer, because it's got a tapered back, ignore this thing here, I couldn't do anything about it. Let's pretend it's not there. The air would come off and then just want to flow down. Now the air couldn't follow this steep of an angle down. But imagine a trailer maybe longer with an arch coming down. So the air would want to come back together off the trailer. This trailer is actually good in this formation here that I'm showing you. It's really made. This is a really high drag form, this Hummer, and towing this trailer this way exacerbates the whole problem tremendously, as you can see. And this is the problem that Fast Lane Trucks was running into. They had a low drag form, a Tesla Model X, and the air was trying to come together and then running into a trailer. And although the trailer was turned around like this, okay, they actually had parts of the trailer came forward like this to help relieve the air, help the air get around the trailer. It didn't do any good because their low drag form was running into the trailer. And when it came off the back, you had this tremendous wake area here in the back. And then plus they have side panels around the wheels here. So this wake area right here is a problem on most all trailers. And it's not addressed usually. So this wake area is going to be bigger than the wake area here on this Hummer. This area right here. So obviously, besides you're towing extra weight, you're going to run into more drag because of a larger wake area. And whatever miles per gallon you get are going to be significantly cut down. So let's set this one aside. Now this is a real caricature of a Hummer, but it's bigger, as you can see. So oddly enough, even though this form here has a higher drag, when it's put towing a trailer like this, the air can come off of it and just attach over the trailer. I mean, it's possible this could even lower the drag coefficient of this combination because of this. Because of this high, really large wake area here, and the trailer itself, you got to consider the trailer and the truck towing it as one vehicle. And the wake area is much reduced on this trailer. So this would probably, potentially could improve your performance or certainly moderate your loss of range over what it would be towing other trailers. So this is a basic problem you run into with all pickup trucks and trailer towing. I'm going to set this aside too. Now here's our Dodge Ram truck. I'm going to put the mirrors out here. Get them out. Come on, you. Oddly enough, the mirrors on most trucks are worth about a horsepower each in loss of range and performance. You can see the mirrors there. Okay? But this is the way trucks normally tow. Now sometimes they'll have a bed cover or not, but the air is going to come up over the truck windshield, and there's going to be a little bit of separation here and loss of energy because of these angle changes. And it's going to come off of here, and then it's going to do a rolling vortex into the bed. Now with a bed cover, you can gain about 5% in efficiency, and so the air could organize again and come off the back, and there would be your wake area right here. Okay? But if you're going to tow a trailer and the trailer's taller than the truck, the air's going to slam right into it. And then it's got to do the whole thing over again of trying to get around and over the trailer. And even though the trailer's tapered in the back in this instance, it's still this area here, this rolling vortex here, and then running into the trailer. It's all bad news aerodynamically. And this could cut your range in some instances up to 50%. take 50% more, twice the amount of energy that you'd normally use going down the road. Now, if you're towing a trailer like this, you really haven't gained anything because of the increased wake area behind the vehicle, which is much greater. And the air comes off here. And although it runs into this trailer and it's got all these rounded edges and stuff, and the air can reorganize over the trailer, when it comes off the back, it's just totally destroyed. So, I know these are vague terms I'm using, but I think you get the general idea. Now, one of the things you can do with a pickup truck for trailer towing is, see if we can get this bed cover I built back on. And there we are. This is just a cab high camper shell. Excuse me. Not a bed cover. And although it increases the wake area of the truck, it actually can improve mileage up to 10% because the air remains organized and resumes laminar flow over the truck, over the cab of the truck, and then finally over the trailer. So it helps the air become more organized. And when you're towing a trailer, it's actually better because there again, now the air can feed. In either situation, the air can feed onto the trailer and around the trailer. So fast lane trucks did a worst case scenario. They were using a low drag form of a Tesla Model X. I used to have a model of a Tesla Model X, and I wish I had it here, but I sent it to a friend to fabricate a boat tail for it several months ago, and he's never got around to the project, so I don't have it anymore. But be that as may, a Tesla Model X, a low drag form, towing a high drag form of a trailer, and the combination of the two is going to be a low drag form. In their case, they were down to 120 miles of range left out of 300 miles of range for the Tesla Model X, not towing. So I thought the whole experiment was completely disingenuous. It lacked controls, it lacked methodology, and they didn't understand what they were talking about. It would be possible to tow a small trailer with a Tesla Model X with a highly aerodynamic form with tapers at the rear, which would would even lower the drag coefficient of the Tesla Model X, and you could get more range. You could go above 300 miles. So it's all dependent on the circumstances of what you're doing. And you have to know what you're doing, and it's all about the air and rolling resistance. The other thing I got into, which I want to explain briefly, I'm going to go ahead and turn this up now so I can talk again to you. Let's see if we can get this up a little higher. There we are. And it's in this paper. It's the amount of energy that's in a gasoline truck. A Tesla Model X has a 100 kilowatt hour battery pack, which is the equivalent of 3 gallons of gasoline. And yet the Tesla Model X can go 300 miles on 3 gallons of gasoline. And so then they throw this trailer into the mix, which really exacerbates the coefficient of drag, and they're down to 120 miles of range. And they say, well, all electric vehicles are just no good for towing. They got a problem. No, you got a trailer problem. You have a high drag form of a trailer problem, and it's a problem with both vehicles. It reduces the range of both vehicles, whether it's gas or electric. The difference is the gasoline vehicle just has tremendous amounts of energy on board to waste. For example, a Ford F-150 with a 26-gallon gas tank, instead of having a 100 kilowatt hour battery pack equivalent in the form of gasoline, it has 852 kilowatt hours of energy available in that gas tank. Now, you have to keep in mind that because of the thermal inefficiencies of gas engines, it throws away 80% of that energy. But still, you're way and above the available amount of energy to turn the wheels going down the road is greater than the 100 kilowatt hour battery pack of the Tesla. My Ford F-150, which has a 36 gallon gas tank, and I'm towing a fifth wheel with it occasionally, and I'm telling you, I need it, that large a gas tank. It has a 1.18 megawatt hours of energy in that 36 gallons of gasoline. Now again, the available amount of energy I have is 236 kilowatt hours for towing. That's assuming 20% efficiency, thermal efficiency. The 26 gallon gas tank is 170 kilowatt hours. So you can see, assuming I'm towing a trailer which is costing me 50% of my range, I would only be able to tow 150 miles with the Tesla Model X, 227 miles with the 26 gallon gas tank Ford, and 315 miles with the Ford F-150. And that turns out to be about what I experienced towing a fifth wheel. So around 50% is what it cost me. And the most I've ever been is 270 miles without refueling, towing my fifth wheel. So, and then I projected one, the Atlas electric truck, which isn't out yet, but would have 500 miles of range, assuming 400 watt hours per mile. I assume it would have a 200 kilowatt hour battery pack in it. It would have 180 kilowatt hours of available energy, and it would have 250 miles of range towing with 50% loss due to towing. So there you have it. I think most pickup trucks, electric pickup trucks, are going to end up in the neighborhood of at least 200 kilowatt hour battery packs. The Rivian, for example, has a 180 kilowatt hour battery pack. And that's what it's going to take. You're going to have to be in that neighborhood to tow. They need to do something about trailers. They're just so dirty. The truckers, long-haul truckers, semi-trucks, they figured this out a long time ago. If you look at all semi-trucks going down the road, almost all of them, the cabs of the truck have fairings which feed the air up over the trailer. Now there's even boat tails on some of these tractor-trailer rigs. And a lot of times you'll see this aerodynamic skirting down around the side of the trailer at the bottom to feed the air around the wheels, the back wheels. A boat tail and this fencing, aerodynamic fencing, increases their MPGs by about 7%. And for long-haul truckers, where every dollar counts, and it adds up because they drive such tremendous distances, this is a real coup financially. And any trucking outfit that ain't doing this is just dumb. But they could do a lot better than they're doing. But when it comes to the average person just buying a pickup truck and towing a trailer, the trailers that are available out there are abysmal aerodynamically. And a lot could be done with it. Another thing that could be done is electric drive could be put in to the trailer itself, especially a travel trailer that people are going to stay in. It would be an electric assist for getting up to speed, going up hills, and so forth. And the battery pack would be large enough, let's say 30 kilowatt hours, so that when they got to a campsite, they'd be able to live without outside power. And this would be a real coup right there. So I'm going to let you go because I'm running out of time, but you get the gist of this. Aerodynamics and rolling resistance is key. There is no magic in the drive. It doesn't matter what powers your tow vehicle. It could be rubber bands. A trailer and a truck combination takes X amount of energy to move through the air, and it doesn't matter what the drivetrain is. Talk to you down the road. Everyone take care. Bye-bye.